Assalamualaikum and a very good day to everyone who watched this presentation. My name is Muhammad Auris bin Hamka, a 4BNT student that would like to present to you about my study on automatic platform gate door rubber alternative design of MRT SSP line project. My study on this topic will be presented on this poster. It will contain abstract, introduction, literature review, methodology, results and discussion, conclusion, and lastly conclusions. So the first one is abstract. When running the cyclic test, the rubber door, which installed as an anti-collision rubber, can slide down and touch the insulation mat of threshold. So with this problem, the purpose of this work is to propose the new design of ASG structure that can hold the door rubber from sliding down. The new design of ASG will have three vertical square holes that provide alternative solution to eliminate the slot frame, which function to hold the rubber on the ASG frame. So the best design will be chosen based on its performance from gravitational simulation test, either the current or new design of rubber door. The new design of door rubber give better comparison than the current door rubber design on the gravitational simulation test. The project background in this project is about automatic platform door. It is a screen door that is often installed at the border of a modern urban, mainline or metro train station's platform. APG is a screen door that is half the height of the train, which typically do not reach the station ceiling or structural beam. Because of that, it do not constitute a complete screen door barrier. So they form a barrier that separates the public area from the track area, limiting access to the track area and preventing passengers, especially children, from entering the track area. The objective of this project is to identify the factor that cause the ASG to get obstacle detection, to develop the 3D model of APG that focus on the ASG frame and the door rubber, and lastly, to examine the performance of current and new rubber door design. The scope of this project has been set to achieve all the objectives. First, the identification method to find the factor that cause the ASG to get obstacle detection is through the detailed observation. By this method, the factor that causing the problem can be found with the combination of physical observation and discussion with the technician about possibilities that lead to the obstacle detection of ASG. Next, the development of 3D model of APG that can be done by using SolidWorks software, which fully focus on the ASG frame and the door rubber design. And lastly, and finally, the 3D model can be examining its performance using simulation of gravitational force, also using SolidWorks to test its durability of the rubber door. Technically, a perfect cyclic test usually runs in 4 hours with 7 seconds per cycle, which means that 1 hour running took 250 cycles, while 2 hours running took 500 cycles, while 4 hours running took 1000 cycles. However, it will take 3 to 7 days to run this test if there is another problems or issue occurs. The issues and problems have been listed as shown in the table in the poster below. So among all the obstacle issues, the rubber door was expected not to have any problems. Instead, the door rubber found to get sliding down and touch the threshold, and this will causing the obstacle detection. So through the observation and discussion with the technician, there is a little gap between the rubber door and the slot. The gap will loosen the friction between the rubber door and the metal surface of the slot, which creating a floating effect. This was happened because when installing the rubber door, the technician used water soap as a lubricant to easily insert and slide the door rubber into the slot. So when in heat or in high temperature, the water soap evaporates, which is a chemical process that transforms water molecule into a gas molecule, which can expand the rubber door and loses the grip between them. So to summarize the methodology process of this project, the block diagram for development of the 3D APG model for the new slot design of door rubber can start by observe the problem or the issue and identify the causes of the problem or the issue, which um, both, both methods have been discussed in the literature review a minute ago. Next, after that, we can produce the idea for the problem or the issue, which is a sliding effect on the rubber door. And then after that, we go through to the preparing the rough sketch of the new design. And then after that, we build the 3D model, which is we have explained earlier. We use a SolidWorks software to build the 3D model of APG because SolidWorks have uh, because SolidWorks have because SolidWorks have been chosen as a design platform to build the two design of 3D models, which is the current design and the new design of the rubber door. And while the gravitational simulation tests were chosen for testing the model's performance, which use the acting gravity force, which is a 9.81 gravity force to simulate stress and displacement for both models. So the results and discussions in this project is based on the comparison graph. The stress for the current design is 14,770 Newton meter square, higher than the new design, which is 1,831 Newton meter square. So the stress received affect the deformation displacement, which is 5.342 millimeter for the current design and 1.726 millimeter for the new design. This is because the acting gravity forces were set on tensile and compressive stress. As the effect from stress, the displacement of the rubber door can be measured because the stress received by the both door rubber design is directly proportional to the displacement for both rubber door design. So the conclusion is that the greater displacement, the easier the rubber door tend to move from its slots. This means that the slot included in the current door rubber design cannot hold or withstand the amount of pressure that coming from the gravity force alone, meaning that the current slot did not have much grip to hold the rubber door for a long time, better than the new design. So the displacement of the rubber door can be measured as a result of stress, even if the numbers of displacements is too small. As a result, the stress received by both rubber door designs is directly proportional to the displacement for both rubber door designs. With all of this data, the new design of rubber door of ASG is a best choice to choose, which can be used for the next MRT3 project rather than the current rubber door design of APG. And that's all for my presentation on my study on automatic platform gate door rubber alternative design of MRT SSP line project. Thank you very much for watching and reviewing my presentation. Hope we can find soon.